So now we consider how would we know if we have clicked on a circular button. So we see this like Facebook profile pictures these days are circles. How do we know if we're hitting inside that circle? So you might want to make your program slightly more interesting to not use rectangular buttons all the time. Now, the answer to this is something that you will probably have done at school, and that is Pythagoras' theorem. So everyone will have, at some point, I can't even write the theorem, will have done something that looks a bit like this. The distance for C is a squared plus b squared rooted. And basically this is a right angle triangle with a hypotenuse of C and two other sides of A and B. And this will allow us, if you know the side A and you know the side B, how can you determine what the length of C is? Now this is something that already exists, and we can use it to figure out whether or not we are inside the radius of a button. So a button consists of my circle button. It has an XY position and it has a radius. So that radius is the diameter divided by 2, and that diameter will be like your width and height of your circle. Now this only works for a circle, okay, so you can't do this if you have an oval one. There's an additional step that you need to do, and if I remember I'll point that out when I get to it. So I have over here my mouse, so this is my mouse cursor. Now I want to determine the distance from this center point to this mouse X position here. And I have to do that to figure how far away that mouse is from the center of my circle. Excuse me. And again. Okay, so to do that I need to draw my right angle triangle, and I've got my formula. My formula is C, that's A, that's B. So my formula is that C is the square root of A squared plus B squared. So how do I figure out what A is? Well, A is, this remember is position mouse X, mouse Y. And so what I'm going to do is I'm going to do mouse X minus my X position, which is the position of my ellipse. And I'm going to square that. And for B, I'm going to do the same thing but using, going to do using the y coordinates. And to make this match up, I am going to call this A and that B, although it doesn't matter what way around you do them. So now I have mouse X minus Y, mouse Y minus Y, correction. So now I have the full thing, is that C is going to be mouse X minus X squared plus mouse Y minus Y squared, and I'm going to root the whole thing. Now, this C here is basically my distance between the center of my circle and my cursor, yeah? So if C, my distance, is less than the radius, then I am inside the circle and I'm inside the button. If C, my distance, is greater than the radius, then I am outside the button, and therefore when I click on it I shouldn't select. So I will put in the description to this a summary bit of code, and the bit of code is basically this formula and setup converted into processing, so you can see how it happens in reality. But this is the theory behind it. This is why that bit of code works, and this is why when you never thought you would use hypothesis, never thought you'd use Pythagoras, we were all wrong.